Yeah, that I have not mentioned. DNA to DNA is known as replication, you know. Okay. So what is the difference between replication, transcription, and translation? It's all about your day-to-day life. It is all about your day-to-day life. Science is not different from your day-to-day life. Everything in the science is from your day-to-day life. Okay. So just think, replication means just like you have what? You have a note. You go to the Xerox center and Xerox it. Okay. So this process is exactly just like your replication. Replication means making an exact copy. Exact copy. That's why making the process of DNA to DNA is known as replication. Okay. So why this process is known as transcription? I have a question. Do you have ever transcribed anything? Yes, you have done it, the transcription many times. You yourself has done this transcription. How? Sometimes you are absent in your class and your friend has done the notes that is given by the lecturer. And you come to the hostel and you just get the note and just try to copy it. Just try to copy it, but you are not making the exact carbon copy. You are not making the exact carbon copy. What you are doing? You are just observing what he has written and you just write the thing. Okay. The language remains the same, but the script is slightly different because he may write the T like this, okay, or R like this. You may write like this, okay. So there is slight change. But the language is not changing. The language remains the same. If he or she has written in the Odia, then you have to. If he or she has written in the English, then you have to. Okay? But you are just some letters, some scripts, you are just changing. Okay? So that's why DNA and RNA both are nucleic acid. So when the nucleic acid is changing to nucleic acid, so obviously language is not changing. But what changing? The script is slightly changing. What script is changing? Because again the script is written in the form of ATGC, but you are now changing the script in the form of AUGC. That's why the name is transcription. So can you please now tell me RNA and protein, why this process is known as translation? Why this process is known as translation? Have you ever done the translation in life? Translation में कौन करा? ये ओडिया इंटरेक्ट में बोला होगा. हाँ, कौन करा translation में?
ओडिया इंग्लिश
इंग्लिश ओडिया करियो कि ओडिया हिंदी करियो एठी लाने लैंग्वेज चेंज होची कोन लैंग्वेज चेंज होची डीएनए रो आरएनए न्यूक्लियोटाइड रो लैंग्वेज रो चेंज होता वर्तमान न्यूक्लियोटाइड रो लैंग्वेज अमीनो एसिड रो लैंग्वेज रो चेंज हो दैट्स व्हाई इट इज नोन एज ट्रांसलेशन नाउ क्लियर ओके शुड वी नाउ मूव my next question is all for you students. Why nature selected DNA as the genetic material? I have told you, one is the repository, that is DNA, one is the middleman, that is RNA, and one is the executioner, that is protein. But my question is, why the nature selected the DNA as the genetic material? Why it is not selected? DNA has sometimes RNA also, but why it is not selecting the proteins, the carbohydrate, the lipid? See, more molecules are there. What is the reason? Any answer from your side? I think you know about this. Something you know about this. Yes. Then we'll discuss what will be the nature of the genetic material, properties of the genetic material. To be a genetic material, what criteria you must have? The first criteria is it should be able to generate its replica copy. So if you go to all the high biomolecules, including RNA, DNA, protein, lipids and carbohydrates, you will find only two of them have this ability. Which ability? Able to generate its replica. Replica formation copying process is only with two. What? DNA and RNA. These are two brothers of nucleotides. Okay. Then, so in this test, in this litmus test, your protein will be paired, your carbohydrate will be paired, your lipid will be paired. Only two of them will own this competition. Then it should be chemically and structurally stable. Okay. So now this test have been passed by only two. Who? DNA and RNA. So now this test, it should be chemically and structurally stable. So among DNA and RNA, which is more stable? Which is more stable?
DNA.
Yes, DNA is more stable. Can you please tell me what is the reason that DNA is more stable? Yes? Just tell me.
DNA. DNA
Why DNA is more stable? Actually, the stability of the DNA is being present in a structure. So, anyone, I think it is a very easy question. So, just anyone have the answer about this? Why DNA is more stable? Double-stranded. Double-stranded sometimes RNA also form doubles, right? I think you know about double-stranded RNA. But is it the main reason? No, I think there is something. Other things is also there. Yes. If anyone have the answer, he or she can tell me. What about you? DNA thiamine ଅଛି. ଆଉ ତାର କଣ ଅଛି? RNA ର କଣ ଅଛି ଯାହା ସେ unstable କରୁଛି? Uracil ର unstable କରୁଛି. Any other thing? Any other thing? Say single helix ଟା କାହିଁକି ବନୁଛି? You have to go there. Although RNA में double बने परिबो एमति किछि नाही. आटा फर्स्ट रूल किछि नाही. Yes. ଆଉ ଗୋଟେ ଜିନିଷ ଗୋଟେ डिफरेंस ଅଛି ତାଙ୍କ ସୁଗାର ରେ. କଣ ସୁଗାର ରେ डिफरेंस ଅଛି? ଦୁଃଖ ସ୍ଟ୍ରକ୍ଚର ତ ଦେଖି. କଣ? Look at here. Look at here. All lies in chemistry. Here the oxygen is there, and here there is no oxygen. I mean, you know about the RNA world. At first, when the life evolved, it is not around DNA. This is down. It is around RNA. But with the passage of time, the nature realized that I have made a mistake. What is the mistake? The mistake is that here the oxygen is present. That oxygen is making what? Making it unstable. How? Because you know oxygen is a reactive element. And it destabilizes what? Actually, during the formation of a phosphodiester bond, you know about the phosphodiester bond? There is a competition between these two. But generally, you know, during the phosphodiester bond formation, this oxygen take one. But here, as there is one more oxygen over there, it will just what? Try to destabilize it. It will try. Why you will take part? Why I not? Okay, this is the main reason. Okay, that's why. And one more thing you tell that uracil. It also makes the what? Structure of the RNA unstable. That's why these two mistakes have been corrected. Nature removed the oxygen over here and just observe uracil. Uracil. 2,4-dioxypyrimidine. Its scientific name is 2,4-dioxypyrimidine. So now it just into nothing. What? It adds only a methyl group to make it stable. Okay, all the problem have been solved. Okay, so now we will take it go back. So this test, one more thing, how much DNA is stable, you can just imagine. Dinosaurs have been passed out by millions of years, but still now we are getting its DNA. Okay, it is not being what? Destroyed. Similarly, I think you know about the Griffith experiment. Griffith experiment, what? He gives the heat to the DNA, but still then the DNA don't lose its property. So how much stable its DNA is, you can just imagine from that Griffith experiment. So from this point of view, this test have been passed by only DNA. It is not RNA. Okay, and it should be provide a scope for slow change. What is the slow change? Slow change means mutation. Mutation is a what required evil. Although it is a evil, but it is a necessary evil, we can say. Okay, why? Because without evolution, without mutation, evolution cannot progress. And evolution is a necessary thing. Because environment is changing. If we are not changing, then we cannot adapt to this. Okay. So in this test also, what? Your DNA will be passed, not the RNA. How? Because mutation, it occurs in both DNA and RNA. But the mutation rate is faster in case of the RNA. Am I right? Can you just give one example of faster mutation in RNA from your day-to-day life? You have just observed it in 2-3 years ago. Yes, very good. The classical example is your coronavirus. How much time it can mutate. Just imagine, within a period of 6 months, how many times it changes form. Okay, so if this changes form will be continue like this, what will happen? Nature have to build up all the machinery once again. That's why it requires a stable repository. That is only by your DNA. Okay. One more thing, DNA is more stable. That DNA, yes, you have to tell the point that DNA is double-stranded. Due to double-stranded nature, the mutagens will not be easily passes through them and change them. Okay. It is one more thing. Okay. We should move forward. So this is the difference between DNA and RNA. You know it better. That's why I am not explaining about this. Yeah. RNA as the middleman. Here is the case. I have told you RNA is the middleman. Middleman, why I have told you it's the middleman? Because it is transforming information from DNA to protein. Huh? But my question is that can DNA play this role of middleman? Or why a middleman is required? Why a middleman is required? Yes. Just tell me. Middleman. In which case middleman is required? Sometimes you made a foreigner that may be what a French. Okay, but you don't understand French. Okay, you are Indian. You just understand Hindi or Odia or English fluent. So what will happen at that case? You will require a middleman, a translator. Yes or no? Who can translate it? So what is the problem behind the transformation of information DNA